So good everybody, depending on the time you are watching this video. So in today's class, we want to look into solubility and solubility curve. Now coming to solubility and solubility curve, this is a key topic in chemistry. Do you understand? Because if you are preparing for JAMB, you need to know this topic very well. And this particular video I'm about to make is not only for JAMBITES, YX students can watch it, NECO students can watch it, and any kind of O-level exam you think of, even JUPEB and 100 level students, because you will be coming across this in your 100 level. You watching this video that is preparing to enter school, you need this video. Do you understand? So you can have a solid background in solubility and solubility curve, because I'm going to be explaining all the things that you need to know once it comes to solubility curves, because this is where students face some challenges. This is why I will implore you to follow this video to the end. Now, this is the class content of what we do be looking. We have definition of solubility, terminologies in solubility, key formulas to take note in solubility. Once you know all these formulas that we are going to be listing out in this video, you are good to go in solving any questions in solubility. Now, points worthy of note. These are key important exam points that you need to take note of. Now, the next one is 15 solid questions on solubility curve. Yes, because once I solve these 15 solid questions in solubility curve, there is no question that you cannot solve on your own once it comes to solubility curves. And this is why I will implore you to follow this video to the end. And if you are new to this channel, my name is Noble C of Noble Team, and I would like you to do what? To hit the subscribe button, like and share this video. You understand? And if you have any questions to ask, the comment section is what? Open. Now we are going to start, but before we start, I will implore you to get a headset, a earpod, or a earpiece, like anyone that will make you to avoid anything like distraction. You understand? Because students face some challenges once it comes to video, because video is not something that you are going to be using your loudspeaker to listen to it. You understand what I'm trying to say? So I will implore you to get either an headset, earpod, earpiece, anyone. Now let's look into the first one, which is what? Definition of solubility. Now, once we hear solubility, what comes to your mind? Now, solubility is how much a solute can dissolve in a solvent. What do I say? Solubility is how much a solute can dissolve in a solvent. Now, I want us to take note of what is a solute and what is a solvent. Now, look at this particular equation. Look at this particular thing that I'm about to write on the board. Do you know we have something like this when we have solutes plus solvents to give us what? To give us solution. Now, once you hear solvents, what is solvent? Solvent appears in a form of liquid. That is what? A solvent. Solvent is what dissolves a solute. You understand what I'm trying to say? Solvent is what dissolves a solute. Now, solute on the other hand is a substance that is being dissolved in a solvent. Solute is a substance that is being dissolved in a solvent. So that is why you dissolve solute plus solvent and you have what? A solution. Now let's take example of shock. Now, shock is a solute on its own. Then solvents that you are going to dissolve it inside, let me say you want to use a liquid of, let me say, water. You understand? And you dissolve it inside water. You have what we call what? A solution. That is why you have solute plus solvent and you have what? A solution. I hope this is well understood. Yes. And let us look into terminologies in solubility. We have terminologies you need to take note in solubility. When we have the saturated solution, do you understand? Because I'll explain what solution is. Because it's when you dissolve solute plus solvent, you have solution. That is where we have terminologies, in solubility, where we have the saturated solution, we have saturated solution, we have unsaturated solution, we also have supersaturated solution. This is a key important point you need to take note in solubility curve. Now I'm going to be taking them one by one and I'm going to be explaining everything that you need to know under this. Now, once you hear saturated solution, what comes to your mind? Now, take note of it, and I hope you are writing. Be jotting down points. Be jotting down all these things I'm saying, because I'm not going to be having time to be writing it on the board, because we have a lot of calculations to solve. Now, what is saturated solution? Saturated solution is a solution that cannot dissolve any more solute at a given temperature. Do you understand what I'm trying to say? A saturated solution is a solution that cannot dissolve any more solute at a given temperature. Now, what do I mean? Imagine you have you are being informed in a lab, or you are being informed in anywhere to dissolve something of 4 grams of chalk inside 100 grams of water, and that is the normal procedure of anything that if you want to dissolve chalk in water. Imagine you dissolve that 40 grams inside that 100 grams, and you went ahead to add another 40 grams of that chalk, to making it a total gram of 80 grams of chalk, to dissolve it in 100 grams of water. Do you understand? So that particular thing is not saturated. What we mean by saturated is when you have 40 grams and you have been instructed to dissolve 40 grams of chalk inside 100 grams of water. That is what we call saturated solution. The next one is unsaturated solution. Now, once in your unsaturated solution is when a solution that can still dissolve more solutes at a given temperature. Now, imagine I have 40 grams of chalk, and I'm being instructed to dissolve it in 100 grams of water, and firstly I dissolved 20 grams in it. You can see that it's still remaining how many? 20. Now, if I dissolve that more 20, you can see, like, if I dissolve more 20, it is what? Saturated. But if I dissolve only 20 and leave the rest, it simply means what? It is unsaturated. You understand where I'm coming from? Now, let's look into supersaturated solution. Now, supersaturated solution is when a solution can still dissolve more solute than its holding capacity at a given temperature. Now, this particular supersaturated solution is something that we have been instructed to dissolve 40 grams of this particular chalk inside 100 grams of water. Now, you dissolve it. That is the normal rule that people use to do what? To produce out things. Now, imagine that you dissolve that 40 grams, and at the end of the day, you dissolve 140. You understand? And you dissolve 140, making it a total of 80. You understand? And at the end of the day, it's still dissolved. That is what we call what? Supersaturated solution. I hope we grabbed what is saturated solution, unsaturated solution, and supersaturated solution. Now, the next one is key formulas to take note in solubility. Now, as I said earlier when we are doing the introduction of this video, that all these formulas that I'm about to list out, once you know all of them, you can be able to solve questions under solubility curves. Do you understand? Now, I'll start by listing out the formulas now. Make sure that you are doing what? Make sure that you are writing. Now, the first one is when we have A. Then we have in gram. When we have solubility in gram, solubility in gram, then we have it to be what? Mass of solutes over mass of solvents. I've explained what solvents is. This is why I started earlier to explain everything. Multiply by what? 100. This is the first key formula that you need to take note. Now, the second one is this. When we have solubility in mole, then it is what? Mass of what? The solutes divided by molar mass. I'll use mm of what? The solutes. Now, the next one, which is the third formula that you need to take note, when we have C, which is the concentration of the solubility, is equal to, solubility is equal to mass over volume. Do you understand where this formula is coming from? Mass over volume. Now, this is the fourth formula that I want us to take note. When we have D, then we have mass of the solutes mass of solutes be right, then divided by molar mass of solvents multiplied by 1000 divided by, pay maximum attention, volume of what? The solvent in centimeter. I will explain. Solvent in centimeter cube. Now take note of this, that in this particular solubility, your volume must be in centimeter. What do I say? Your volume must be in centimeter. Imagine in a question that you are giving something of in decimeter, which is in dm cube, to solve. You are going to convert it to what? To centimeter cube. That is what I'm trying to explain. Now the next one is when we have the fifth formula, which is the last formula. We have mass of solutes divided by what? Mass of solvent. Molar mass of solvent, sorry. Molar mass of solvent times 1000 divided by, no, this is mass. Do you understand? Sorry, this is mass of solvent, then divided by what? The molar mass of the solute. Molar mass of what? The solutes. Do you understand? Now I will implore you to do what? To allow these formulas to stick into your memory, because once you know these 5 formulas that I've listed out, you can be able to tackle any questions under solubility and solubility curves. Now this is what? The mass of the solute divided by molar mass of the solvent multiplied by 1000 divided by volume of the solvent in centimeter cube. Now the fifth formula is mass of the solute divided by mass of the solvent multiplied by 1000 divided by what? Molar mass of the solute. I hope these particular formulas have stick into your memory, because you'll be asking, when will we be able to do what? To know the type of formula that we are going to see and the type of formula that we are going to use. Now this is what I'm going to tell you. The question and the parameters in the question determine the formula that I'm going to use. And you are going to be solving questions. You are going to be seeing the amount of formulas, parameters given to you, and the type of formula that you are going to choose to solve this particular this particular question. So it is very, very simple. This is why I will implore you to do what? Follow this video to the end. Now the next one is points worthy of note. Now I'm going to be listing out key important points to take note. Now in solubility, it is plotted, solubility is being plotted against temperature. I hope this point must be noted. Now this is where I have one, the graph is like this, and when we have solubility, I'm not going to write it in full, and this is what? Temperature. In solubility graph, solubility is being plotted against temperature. Now the next point is this, that in solubility, when solubility increases, the temperature increases. This is being applied in solid and liquid. In solid and liquid, when the solubility is increasing, the temperature is doing what? Increasing. But in gas only, when the solubility decreases, the temperature will do what? Will increase. I hope this point must be noted. Now the next one is 15 solid questions on solubility curves. 15 solid questions on what? Solubility curves. Now let's solve question number 1. Alright, now let's solve question 1. Question 1 says, when 50 centimeter cube of saturated solution of sugar, and we have the molar mass to be 342 grams at 40 degrees Celsius, was evaporated to dryness, and we have 34.2 grams of dry solid was obtained. The solubility of the sugar at 40 degrees Celsius is what? Now look at this particular question. Which particular formula are we going to be using? We are going to be using the formula that says when we have solubility is equal to mass of the solute divided by molar mass of the solute multiplied by 1000 divided by what? volume of the solvent in centimeter cube. Now let's write out the parameters and solve, because we are asked to get the solubility in mole per dm cube. Now we have x is now equal to, this is s, is now equal to, what is the mass of the solute? The mass of the solute is 34.2 divided by, what is the molar mass according to the question? We have it to be 342 multiplied by 1000. Now coming to this particular question, is our volume in centimeter or dm cube? Our volume is in what? In centimeter cube. So we are going to be writing what? 50. Then 50. Now the next thing, what are we going to do here? If it is me, this is how I normally solve my own. I'll first and do what? Divide this first. Bring out the answer. Divide this, then multiply it. Now I will employ it to do what? To get a calculator. Now the reason why I'm using my phone calculator to solve is this. It's not just that I don't have all this engineering calculator. I have it, but the phone calculator, because I will advise you to master the phone calculator, because this is what you are going to see as a student preparing to write JAMB. This is the type of calculator, like the calculator in your phone. This is exactly the type of calculator that you are going to be seeing in your exam. You are not going to be seeing all this scientific calculator. That is why you start now to master this calculator on your phone, because this is the exact type of calculator you will see on your system that day. Now I will employ you to follow me and do what? And do the calculation. Now let's divide. Once you have 34.2 divided by 342, then we have 0.1, then 0.1. Once 1000 divided by 50 will give us what? 20. Then you have 0.1 multiplied by 20, then we have it to be what? 2. We have it to be what? 2.0 mole per dm cube. We have it to be 2.0 mole per dm cube. I hope you all understood how we arrive at this answer. Now let's solve more questions so you can be able to do what? To know how to solve questions under solubility curves. Now let's solve question 2, and I want us to correct this in our notes, because when we are treating key formulas in solubility, now this particular point must be noted, because I think I made a mistake earlier. Now this is the correct formula. When we have solubility is equal to mass of the solute divided by mass of the solvent multiplied by 1000 divided by what? Molar mass of the solute. Molar mass of the what? Of the solute. This point must be noted. I hope this is well understood. Mass of the solute divided by molar mass of the solvent. Do you understand? No, not molar mass of the solvent. Mass of the solute divided by mass of the solvent multiplied by 1000 divided by what? Molar mass of the solute. Now let's look at this question. We have the solubility in mole per dm cube of 20 gram of CuSO4 dissolved in 100 gram of water at 180 degrees Celsius is what? Now which formula am I going to be using? This formula that I listed out now, which is solubility is equal to mass of the solute divided by mass of the solvent multiplied by 1000 divided by what? Molar mass of the solute. Now looking at this particular question, I want us to first and get the molar mass of the solute. Now what is the molar mass of the solute? Which is CuXO4. Then copper here is what? 64 plus our sulfur here is what? 32. Then plus 16 times 4. 16 multiplied by 4 is what? 64. Then sum it up. 64 plus 64 plus what? 32. Then we have it that the molar mass of this particular thing is what? Which is CuSO4 is what? 160 gram per mole. Now let's put in the parameters given to us in the question. Now in this particular thing, our mass of the solute is what? 20 divided by our mass of the solvent is what? 100. then multiply by 1000 divided by the molar mass of the solute, which is what? 160. Now let's do our normal calculations. Once you 20 multiplied by 1000 will give us 20,000. Then 20,000 divided by 100 multiplied by 160. We have it to be what? 16,000. Then 20,000 divided by what? 16,000. We have it to be what? 1.25 mole per dm³. This is the what? The final answer. Now let's look into the question to know which option is correct. Option A is correct. Now this is why I say that the type of question determines the type of formula that you are going to use. You understand? Make sure you do what? You correct that formula. Now let's look into question 3. Next one is question 3. Now question 3 says 16.55 gram of lead 2-trioxonitrate 5 was dissolved in 100 gram of distilled water at 20 degrees Celsius. Calculate the solubility of the solute in mole per dm³. Now I want you to take note of this, that in solubility, for you to be able to master solubility very well, you need to do what? You need to know how to calculate molar mass, and also know how to get the chemical formulas of a particular compound by name. Because in solubility, they will not, sometimes in a question, they will not give you the what they call it, they will not give you the chemical formula of the compound. Do you understand? You will be yourself to do what? To bring it out. So that is why it is very advisable for you to do what? To know how to do what? How to get the chemical formula of a compound. Now this question, first and foremost, I want us to get the molar mass of this compound, lead 2-trioxonitrate 5. And this is lead 2-trioxonitrate 5. When we have Pb into bracket, this is Pb lead, which is NO3 bracket what? 2. This is lead 2-trioxonitrate 5. And in this particular question, we are asked to calculate the solubility in mole per dm³. Now, which formula are we going to use? This particular formula that we used. Now, what is the mass of the solute? The mass of the solute is what? 16.55 divided by mass of the solvent is what? 100 grams. Now, I want you to take note of this, because this is a key important point. Now, you will notice that when we are solving when we solve the first question, I think the second question, the mass of the solvent was what? 100 grams. Now, take note that the mass of solvent, which is for water only, is what? 100 grams. You understand? It is constant. The mass of solvent, which is water, is what? Is 100 grams. Now, looking at this question, it says that it's dissolved in 100 grams of distilled water. Then we have it to be what? 100 multiplied by what? 1000 divided by the molar mass of this. Now, let's solve the molar mass of this particular guy. Now, what is the molar mass of lead? Lead is what? 27 plus nitrogen is what? Nitrogen, the molar mass of nitrogen is 14. Now, 14 multiplied by 2 will give us 28. Plus, then we have, take note of this, 3 multiplied by 2 is what? 6. Then 6 times 16. 6 times what? 16. When we have 6 times 16 is what? 96. Then let's sum it up. 96 plus 207 plus 28 is what? 331 gram per mole. I hope you understood how I arrived at this. Now, let me just throw more light on this particular molar mass. Imagine you have a bracket. You understand? A compound that have a bracket, and you are having a number that is being what? Subscript in this particular equation, like according to this. This particular 2 is going to multiply everything in this bracket. Something that, imagine I have something of 14, and I also have 3, and I also have plus 2. Now, what am I going to do here? 14 is going to multiply this, and 14 is also going to multiply this, because in case of board mass, board, which is brackets, is like will be the first. Do you understand? Before addition process. This is why 14 will multiply this, 14 will also multiply this, then you sum it up. This is what I mean by this particular thing. So now, this is how I arrive at this, and I also have 3, 3, 1. Now, the next one is to do our normal substitution, where we have 16.55 divided by 100. I have 0.1655 multiplied by 1000 divided by 331. I have 3.021. Then multiply by 3.021 multiplied by 0.1655. 0.1655. I have it to be 0.4999. So to approximate it, I have 0.5 mole per dm cube. This is the word final answer. Now let's look into the question to know which option is correct. Now coming to this question, option C is correct. 0.50 gram per. How is it gram? 0.0, because in the question we are asked to calculate the solubility of the solute in mole per dm cube. So it is mole per dm cube. Do you understand? They just want to confuse you. 0.50 mole or 0.50 gram according to the question. Now the next one I want us to look into is question 4. Now question 4 says at 27 degrees Celsius we have 58.5 gram of sodium chloride, which is what salt, is present in 250 centimeter of solution. The solubility of sodium chloride at this temperature is what? And we have the molar mass of the sodium chloride to be 111.0 gram per mole. Now once you hear volume, it simply means that you are making, like you are using the formula that do what? Involve volume. This is very, very simple. Now which formula are we going to use? I'm going to be using the formula that says when we have mass of the solute, do you understand, divided by molar mass of the solute. Look at this way, because I'm looking at this question and be reading out the type of formula that we are going to be using. Mass of the solute divided by molar mass of the solute multiplied by 1000 divided by what? The volume of the solvent in centimeter cube. Now I'm going to be using here to solve. I think we can see up to here. Now what is the mass of the solute, which is 58.5, divided by what is the molar mass of that sodium chloride? 111, right? Then multiply by 1000 divided by what? Divided by 250. Divided by 250. Now let's substitute. I have 58.5 divided by 111. I have it to be 0.527 multiplied by this divided by this will give me 4, because 4 times this is 1000. Then I have 0.527 multiplied by 4. I have it to be 2.108. Now approximately, if I want to convert it to a whole number, it is going to be 2.0 mole per dm cube. Now which option is correct? We have option B to be correct. Now I'm going to be wiping the board now, so you can have enough space to solve more questions. And if you're enjoying this video, make sure you do what? You hit the subscribe button for me, like this video, share it to your friends here so they can do what? They can benefit. Now question 5 says if 10.5 gram of Lit2 trioxonitrate 5 is dissolved in 20 centimeter cube of distilled water at 18 degrees Celsius, the solubility of the solute in mole per dm cube is what? Now I want to give you a little trick. Do you understand? Very, very simple. This is a very short cut that I normally use to solve any questions on solubility. Now, once you hear anything volume, you do what? You record the formula that have volume. Do you understand? Once you hear a question that did not involve volume, but you are given to solve for the mole per dm cube of that solubility, do you understand? You record the one that do not involve what? Anything like what? Volume. I hope this is well understood. Now, looking at this question, which formula are we going to be using? The one that involves volume. Now, where I have solubility, which is S, is now equal to what is the mass of the solute? The mass of the solute is what? 10.5 divided by what is the molar mass of the solute? I've solved for this molar mass in question 4, where we have 331. Do you understand? 331 multiplied by 1000 divided by what is the volume of the solvent? What is the volume of the solvent? Now, the volume of the solvent is 20 centimeter cube. Now, let's do our normal substitution. Make sure that you are writing. Make sure that you are doing what you are writing. Now, 10.5 divided by 331. We have it to be 0.0317. Multiply by this into this is 5. I think. Yes. Let me just 1000 divided by 20. Let me be sure. 50. Sorry. Because this cancel this. 2 divided by this is 50. So 50 multiplied by 0.0317. I have it to be 1.585. So now let's look into the option to know which one is what is correct. So we have option A to be correct, which is approximately 1.60. Yes, because once you approximate this, it is 6. The rest is what? 0. Now let's look into question 6. See, let me tell you, once we solve questions, these 15 solid questions, there is no question you cannot solve. Do you understand? As I said earlier in the previous video that I posted, that the easiest way to learn is when I solved up to 3 calculations, then the next calculations, you will be the one to do what? Solve it. How are you going to solve it? You will pause the video. Once you pause the video, you do what? You will solve. Then listen to the explanation of it to know if you are correct. This is the easiest way to learn. You understand? Now let's look into question 6. Now question 6 says, calculate the maximum mass of crystals that will be obtained from a 20 centimeter cube of solution of this particular equation that I'm seeing, because this particular chemical formula I'm seeing rather is something that I've undergone crystallization of water. Do you understand? Water crystallization. That is where you'll be seeing .H2O. Once you hear .H2O, it simply means that particular solute have undergone water crystallization. If its solubility at 250 degrees Celsius is 45 grams in 1 dm cube of water. Now, coming to this question, which formula are we going to be using? Now, looking at this, remember when I stated that we have C is equal to mass divided by volume. Now, what are we going to be doing here? I'm going to be doing mass over volume, which is 1 divide is equal to mass 2 over volume 2. Now, why am I going to be using this? In this question, we have 2 volumes and we also have one mass, but we are asked to get the mass of the other one. Do you understand what I'm trying to do? Yes. Now, let's move. What is the Fox mass? They say calculate the maximum mass of the crystals that will be obtained from a 20 centimeter cube of solution if its solubility is 45 grams in 1 dm cube of water. Now, this is this. Once I have the first mass is unknown, divided by what? 20 cm cube. Do you understand? 20 what? 20 cm cube. Then it's now equal to the second mass is what? 45 grams. 45 divided by the second one is what? The second mass, no, the second volume is 1 dm cube. Now in 1 dm cube, which particular dm cube am I going to, because am I going to be using dm cube? No, I'm going to be converting it to do what? To what? To centimeter cube. Now 1 dm cube in centimeter is equal to what? Like, look, let me explain something. 1 dm cube to centimeter cube is what? Is 1000 centimeter. So is what? Is going to be what? 1000 centimeter cube. I've converted it. Now making this M1 subject of formula, I have M1 is now equal to 20 multiplied by 45 divided by 1000. Divided by 1000. Now let's multiply. Divided by 1000. 20 multiplied by 45, which is what? 900. 900 divided by 1000 is what? 0.1. It simply means that the Fox mass is going to be what? 0.9 gram. Now let's look into the question to know which option is correct. Option D is what? Correct. You can see how I solve this, because we can also choose the other way around to solve this particular thing. You can also use this to solve. Now let me explain how you can use this to solve. Now the first mass, no, not the first mass, the red, like the second mass, where we have this particular C. Let me use my blue marker, my blue pen, so you can understand what I'm trying to do, because I want you to understand this particular thing very, very well. Now imagine I have this C, then C is now equal to 45 divided by what? 1000. Now just pay maximum attention, which is 45 divided by 1000 is what? C is now equal to 0.045. I've gotten my what? C here. Now the next one is I want to get the what? The rest. Now I have C. I'm going to be writing 0.045 is now equal to, my Fox mass is unknown. I'm going to be writing mass divided by the volume of this is what? 20. You understand? Now making this subject of formula is going to be what? 20 multiplied by this, multiplied by 20. I'm also going to be having what? 0.9 gram. You can see it is the same. Do you understand? So this is the what? The easiest way to solve this particular type of question. That is why I don't go through this particular spreads to solve it, because anything exam, be it CBT, because 100 level exam are always CBT, and even JAMB are CBT. You need something that will do what? Will help you to save time ahead of other questions, because you'll be writing 4 subjects if you are writing JAMB exam, because it's what? 4 subjects. So it's not, you are not going to be using log method. I want you to be using what? Short method. This is why I use this, the ratio of 1 and ratio of the rest. Now the next one is question 6 or question 7, because I have solved question 6. Now question 7 says dash is called the universal solvent. Now this particular thing is something that you have known already when you are in XS1. Now once you get this particular thing, we have option A is what? Oil, B petrol, C ethanol, D water. The universal solvent is what? Water. Now what do I say? Why do I say water? Ethanol now is being mixed with water. Do you understand? Anything that you are using on this earth deals with water. Even this particular petrol, even this particular oil. Do you understand what I'm trying to say? Now this is why water is a universal solvent. If you don't know it today. This is a core this is a core JAMB question, and you can see how it just it's very, very simple, but some people will still fail it because they do what? They don't know it. Know it today. Now the next one is question 8. Question 8. Calculate the solubility of 10.1 gram of potassium nitrate or potassium nitrate, or we call it potassium also nitrate 5, that is being dissolved in 50 gram of distilled water at 250 degrees Celsius. Now let's solve. Which formula are we going to be using? The one that do not involve volume. Do you understand? The one that do not involve what? Volume. Now what is the molar mass of this potassium nitrate? Now this is the chemical formula for potassium nitrate, where we have KNO3. This is what? The chemical formula. Now Potassium is what? 39 plus nitrogen is what? 14. Then plus oxygen is what? 3. Yeah, then 3 multiplied by 16. 3 multiplied by 16, we have 48. Then sum it up. Plus 14 plus 39, 101 gram per mole. This is the molar mass of potassium nitrate. Now let's look into this particular question and solve. Our mass of the solute is what? 10.1 divided by our mass of the solvent. Our mass of the solvent is 50. Then multiply by 1000 divided by the molar mass of the solute. The molar mass of the what? Solute. That is where we have 101. Now let's substitute, because in the question we are asked to solve it in terms of mole per dm cube. Now 10.1 divided by what? 50 is what? 0.202 multiplied by 1000 divided by 101. That is where we have 9.9 multiplied by 9.9 multiplied by 0.202. We have 1.9998, which is approximately 2.0 mole per dm cube. Now let's look into the question to know which option is correct. Option D is what? Correct. 2.0 mole per dm cube. Now you will notice something, that we have been solving questions on this. You understand? But do you notice one important thing here? Now in solubility, it is being rounded up to what? To 2 decimal places. And the 2 decimal places, the last number at the back is what? Always 0. Now what do I mean? Imagine I have something of 1.69. Do you understand? It's going to be what? 1.70. It's not going to be what? 1.69. Do you understand? You will be seeing questions that we are solving, because coming to this particular is 1.999, 999 and so on. Because coming to this, if I approximate it, it's going to be what? 2.00 grams. This is what I mean. It is always in 2 decimal places. Alright, now let's solve question 9. 117 grams of sodium chloride was dissolved in 1.0 dm cube of distilled water at 25 degrees Celsius. Determine the solubility in mole per dm cube of sodium chloride at that temperature. Now, what is the formula that we are going to be using here? Since it involves volume, we are going to be making use of the formula that involves what? Volume. Now, our solubility is now equal to mass. Let me use here. Solubility is now equal to mass of the what? Of the solute. What is the mass of the solute? 117 divided by what is the molar mass of the solute. Now coming to this, we don't have the molar mass of the solute. We are going to solve, which is what? NaCl. NaCl. Now sodium is what? 23 plus my chlorine is what? 35.5. This is 35.5. Then once you sum up, you have the molar mass of it to be 23 plus 35.5, which is 50, which is what? 58.5 gram per mole. This is the molar mass of it. Then I will be having what? 58.5 multiplied by 1000 divided by 1000. Do you understand why I did here? Why is it over 1000? Because 1 dm cube is equivalent to the what? 1000 centimeter cube. Do you understand? Now, this I've already cancelled out this, and I have 117 divided by 58.5. I have it to be what? 2.0. Now, I want you to pay maximum attention in this. in solubility, it is not a must that you will be given the relative molecular mass of a certain element. For example, sodium, the rest, and so on. You like in a question, they will not give it to you. They will want you to use your heads and do what, and do the calculations to each molar mass. So that is why it is advisable for you to know the molar mass of some certain element, at least the first 30 elements, because it's going to help you a lot. You understand? Now let's look into the question to know which option is correct. Option A is correct. You can see we have solved solid 9 questions and the remaining 6, and we are going to be solving up to 13, and 2 is going to be an assignment for you to solve, because after solving these 15 solid questions, there is no any question you cannot solve on your own. Now the next one is question 10. Now question 10 says, for which salt in the graph above does the solubility increases most rapidly with rise in temperature? Now remember when I said that in solid and liquid, as the solubility is increasing, the temperature is what? Also increasing. Now you're going to be seeing the graph on your screen. Now the potassium nitrate, which is KNO3, is being aligned at 70 more at 70. Do you understand? At the y-axis, which is the solubility, you will be seeing it on your screen. At the what? At the solubility. While the rest are below it. Do you understand? So the question now says, for which salt in the graph that its solubility increases? Do you understand? And also in the rise of what? Temperature. It simply means that what? The solubility of KNO3 increases the most, which is at the top of what? 70. It simply means that KNO3.
My name is Miracle, and I scored 313 in the 2025 UTME examination with the help of Noble Team 9 classes. Oh my god, the class has been amazing. I did math, physics, chemistry, and English, and the lectures was top notch. Like, I can't believe I could score 98 over 100 in math. Like, Noble Team made my dream come true. You know, with the help of our mentors, you know, they didn't give up on us. You know, their teaching was just outstanding. You know, Noble Team made my dream come true. I just thank Noble Team, because it made an impossible dream, which seemed impossible at first, you know, to become a reality. Thank you, Noble Team.
Alright, now let's solve question 11. Question 11 says the solubility curve of a solid X molar mass is 160 is as shown above. You see the graph on your screen. Then 1000 centimeter cube of saturated solution. Once you hear centimeter cube, you can record the formula that you can use to solve. You understand? And also 1000 centimeter cube of saturated solution of X at 80 degrees Celsius is cooled to 40 degrees Celsius. The weight of X crystallized out will be what? So we are going to be using the formula that says solubility in mole per dm cube is equal to mass of the solute over molar mass of the solute multiplied by 1000 divided by what? The volume of the solvent in centimeter cube. Now in this particular graph, because this particular solubility curve, we will be considering temperature. Very, very important, because in the previous question that we solved, we are not considering temperature. Because why? It did not involve anything like what? Graph. But once it comes to solubility curve and it involves graph, your main concern should be on that temperature. Now looking at this, do you know that in this question we have the value of the solubility in mole per dm cube? Now the question says 80 degrees Celsius and also cooled to 40 degrees Celsius. Now for us to get our solubility in mole per dm cube, now 80, like look at the graph. 80, which is the temperature, trace it to that word solubility in mole per dm cube on the graph. You will see that is in what? 0.4. You will see that the solubility is what? 0.4. Then we also have that the one of 40 is located in minus 0.3. Once you subtract this, you have 0.1 mole per dm cube. Mole per dm cube. You can see that we have gotten our solubility in mole per dm cube. Now you come and put it in the main formula. Now which one is the main formula? Where we have 0.1 is equal to m over 160 multiplied by 1000 divided by 1000. This will cancel out this, and we have m is now equal to 0.1 multiplied by 160. Now if you multiply this, I think it will give you something around 16 grams. Let us multiply so we can be sure of what we are saying. 0.1 multiplied by 160, yes, 16 grams. Which option is correct? Now we have option D to be correct. Now just take note of the point that I just said, that we are considering temperatures in the question once graph is being given to us. Now let's solve more questions so you can understand more better of what I'm trying to say. Now question 12. Question 12 says, from the diagram above, the mass of crystals deposited when 1 dm cube of a saturated solution of NaCl is cooled from 80 degrees Celsius to 60 degrees Celsius is what? Now we are asked to get the mass of the solute. We are still going to be using this same formula, and also it's the same graph. Now looking at this, let's trace 80 from this graph. If you trace 80 is at what number? It is at number 10. This is where we have 10 minus, then you trace 60. 60 is at what point in this graph? 60 is at the point of what? 8. Then we have it to be 2 mole per dm cube. So we have gotten what? The dm cube of it. Do you understand? And I want to explain something. Now, if you have a graph like this, it's very, very important. Make sure that you are writing. You have a graph like this. Do you understand? And we have 0. We have, let me use 2, 4, and 6. And this is a point. This is a point. And this is a point. Now, in a question, you are being asked to trace 6 and 4. Do you understand? 6 and 4. And you will notice that if this line do not meet at this point, do you understand? If it is below that particular line that it's supposed to meet, it is what? Unsaturated. But if it met at this point exactly, it is what? Saturated. But if it is above this, it is what? Supersaturated. So I want you to take note of this particular thing. It is very, very important. So now in this question we have gotten what? Our moles, our mole, solubility in mole, and we have it to be what? 2 is now equal to mass over. What is our molar mass in this question? We have to calculate for it. I think the molar mass is 58.5 because this is 23 plus 35.5. Once you multiply once you add this, you have this. Then it is what? 58.5 multiplied by 1000 divided by 1 dm is what? 1000. Then this we cancel out this, and we have 2 multiplied by 58.5, which is equal to m. Then m is now equal to what? I think is 117. 117, no, not 117, 17. 2 times 58.5. Yes, 117 grams. Now let's look into the question to know which option is correct. Now we have option A to be correct. Now let's solve one more example, then I'll give you the 2 as an assignment, because we have solved up to 13 solid questions that we want to solve now, and I'll give you 2 as an assignment because we are already done with this. Do you understand? Once we solve one question, then we are done. And this is very, very simple because I explain everything you need to know under solubility. Now this is the last question. It says the diagram above is the solubility curve of a solute X. Find the amount of X deposited when 500 centimeter cube of solution of X is cooled from 60 degrees Celsius to 20 degrees Celsius. Now for us to be able to get, what did they ask us to get? The amount of X deposited. So now let's first and get our solubility mole per dm cube. Now trace 60 degrees Celsius. Once you trace 60 degrees Celsius, you can see that it is a point of what? 5.5. I just explained this, and at that point for 5.5, it is what? Supersaturated. You understand? It is supersaturated. Now we have 5.5 minus, then we trace 20 degrees Celsius. 20 degrees Celsius is a point of what? 4. Then once you multiply this, it is 1.5 mole per dm cube. Now we now have 1.5 is now equal to. Now in this question we don't have the mass and we also don't have the molar mass. Now how can we be able to succeed? Now remember when we are solving this, I gave you guys a formula that is when we have m, which is the solubility moles, then we have the mass over molar mass. Do you remember when I said so? Now we are looking for this particular thing now, but we don't have this, so we are going to be representing with what? M only. Do you understand why I did here? M only multiplied by 1000 divided by what? 500. Do you understand why I did here? Yes. Now let's move. So if this multiply this, or rather we have this divided by this is now equal to 2m, because this divided by this is 2, this into this, 5 divided by this is 10 divided by 5 is what? 2. Then making m subject of formula, we have m is equal to 1.5 divided by what? 2, and we have it to be 0 point something, I think 0.75. let me just multiply, let me just divide to know if I'm correct. 1.5 divided by 2, yes, 0.75 moles, because we are asked to get the amount of X that will be deposited. You understand why I did here? Now we are done with solubility curves, and this particular thing is a solid video that you need to watch to the end, and make sure that you submit the assignment, you do the assignment, because it's part of discipline that you do what? You learn something from this video. Don't forget to share this video to your friends, subscribe to this YouTube channel, and also if you have any question to ask, the comment section is wide open for you to ask questions. So if you want to know more about us, so this particular video is being made by what? Nobutin. Nobutin is an online educational platform that provides quality and intensive lectures for students preparing for WAEC, NECO, JAMB, GCE, School of Nursing, Post UTME, and any kind of O-level exam you would think of. If you want to know more about us, the video description where you see a link, and it will lead you directly to our website. And if you want to contact us, make sure you do what? You text the number on your screen. See you in the next video. Bye.